All right, today we are diving into a process that honestly feels a little bit like magic, but it is absolutely fundamental to the world we live in. We are talking about electroless plating, a seriously cool chemical trick that lets us coat almost anything in a perfect shimmering layer of metal.
So let me start by asking you a question. Think about this. We all kind of know you can use electricity to plate metal onto another piece of metal, but how in the world would you get that same flawless mirror-like finish on something that doesn't conduct electricity? Like a piece of plastic or a ceramic vase. It seems like it should be impossible, right? Well, there's a brilliant chemical solution, and that's what we're here to talk about. And the answer is a process that works without a single jolt of electricity. It's almost like a modern form of alchemy, and it has become a total cornerstone of how we make things today.
Okay, so the official name is electroless plating, or if you want to get technical, autocatalytic plating. So instead of using an external power source to force metal onto a surface, this whole method relies on a super carefully controlled chemical reaction happening in a liquid bath. That's it. It's pure, elegant chemistry just doing its thing.
So you're probably wondering, how does this chemical method stack up against the one we've all heard of, electroplating? Well, the differences between them are actually what make electroless plating so incredibly versatile and, frankly, so powerful. Let's break it down. Electroplating, well, it needs electricity and a surface that can conduct it. Electroless plating, it works on pretty much anything. Plastics, ceramics, you name it. But here's the real game changer, the uniformity. With electroplating, the coating can get thick in some spots and thin in others, especially on complex shapes. But an electroless coat, it's perfectly even. Every single nook, cranny, and curve gets the exact same thickness. It's amazing.
Okay, so how does this chemical wizardry actually happen? I mean, how do you just convince metal to, well, grow on a surface all by itself? This is where the process gets really, really clever.
So it all starts when you dip the object into this special chemical soup. On the surface of that object, a catalyst is waiting to get the party started. It kicks off a reaction, which makes the metal ions floating around in the bath start to deposit onto the object. And here's the autocatalytic part, the part that's so cool. That new layer of metal that just formed, it's also a catalyst for the reaction. So it's like the first layer of metal tells the next layer, hey, come join me. And so on, creating this perfect continuous skin, one uniform layer at a time. Now, for this whole thing to work, the chemical bath has to be just right. It's a really precise cocktail. You've got your metal salts, that's the actual nickel or copper you're depositing. Then you have reducing agents, which are kind of like the engine driving the whole reaction. And on top of that, you have a whole team of other chemicals that keep everything stable, controlled, and running just the way it's supposed to. And you should know this isn't some old, dusty technique that never changes. Oh no, this is a field that's constantly innovating, with scientists and engineers pushing the limits of what these incredible coatings can do. For instance, recent research has been digging into creating these really advanced black nickel coatings. And they're not just for looks. By combining the electroless plating with an oxidation treatment, researchers can create these amazing layers that have unique optical and protective properties for all sorts of high-tech stuff. People are even finding ways to make the process itself better. I mean, check this out. Scientists found that if you add ultrasonic waves, basically really high-frequency sound, to the chemical bath, you can dramatically reduce any tiny little holes in the coating. The result? The final layer is denser, stronger, and performs way better. So, okay, this is all fascinating chemistry, but why does it matter? Well, its unique set of skills has made it an absolutely essential tool in creating the modern world, often in ways you don't even see. So, let's just quickly recap the superpowers of this technique. 1. It creates what are called conformal coatings, which is a fancy way of saying it perfectly hugs every microscopic detail of a complex shape. 2. You get incredible control over how thick the coating is. And 3, the big one, it works on non-conductors like plastics, which is a total game changer. And because it can do all that, this technology is, well, it's everywhere. It is absolutely vital in electronics for making those tiny conductive pathways on circuit boards, inside your phone, your computer, everything. It's used for those super high-quality metallic finishes on car parts and home fixtures. And it's even being used on the cutting edge in things like 3D printing and creating advanced, super lightweight composite materials. And that really brings us to a final thought, doesn't it? This technology gives us the power to put a perfect, functional metal skin on pretty much anything we can dream up. So with that kind of incredible precision and versatility at our fingertips, it just makes you wonder, what seemingly impossible things are we going to build next?